Okay, so we're going to do the workshop review. The first part of this, I'm just going to bring up RAS and we'll walk through. And if you had a question about some of the data, that would be the time to answer it. So the way you did this is you used this SA2D connector button and you drew the center line from left to right. From there, you clicked on it and said edit internal connection, okay, and you gave it spacing, okay. And then from there, you enforced it, okay. And I saw some use different cell size spacing. That's okay, no problem, whatever you want to use. I used, and I think I had in the workshop to use 60 and then 120 for the 60 for the minimum, 120 for the max. In the example during the lecture, I had 30 and 30, but that was a different bridge location. Okay. Then once that's done, you edit it, okay. And the first step was to make sure the structure type was set to bridge. And then from there, you entered the deck and the roadway. And in this case, we told you that it's 40 feet wide, okay? And use 20 feet for the distance to the upstream and downstream cross sections away from the bridge deck. And then the station elevation data, station high chord, low chord for the upstream and the downstream side. And that's all you needed to enter for that. And then that's going to give you this bridge deck. The next step was piers. So any questions? If you have a question, just go ahead and ask about the data if there's any question on it. But it should have been pretty straightforward because it's basically the same as 1D. So there were two piers. We added pier 1, center line 125. The pier widths were 2 feet. And low elevation below the ground, high elevation up into the bridge deck. And then it clips them off from the ground and the deck for you. And then there was a second pier. You could have just done copy and then give it a different upstream and downstream stationing. There were no abutments to add in, no sloping abutments. So the next step was the bridge modeling approach. Okay. And we're just using energy for low flow and pressure and weir for high flow and the default coefficients. So nothing special there. And then lastly, then the H-tab parameters. I like to increase these. So there's some defaults and I always set these to the maximum because I want as many points and curves as possible. So I always set the number of points in the free flow curve to the max, which in this case is 80. And I up the number of submerged curves to 60 and number of points in the submerged curves 50. And then I made a decision of how high to make the curves. In this case, I want to be able to account for overflow and I want it high enough. So I went up to 575, okay, which is 5 feet above the top of the road, thinking that we're probably not going to get water more than 5 feet above the top of the road. And then I didn't put in a maximum flow.
Gary, does the reference manual kind of give us an idea about what range should we be thinking in, or is this just experience as you go through it?
The range is you have to have that high enough so you capture every possible water surface that might occur in the model. So one problem is, let's say you develop a model and you're running like, 2 through 100 year. Great, you got an elevation set. Now someone takes your model and they do a dam break because there's a dam upstream. And they run the dam break and the water gets way higher than 575. Well, what's going to happen is a warning message is going to come up and tell you that, hey, the curves for Highway 150 were exceeded. And so if you see that warning message in a run, that's telling you that, hey, whatever structures you have out there that curves are built for, the elevation doesn't go up high enough and it's extrapolating. Okay, so that should tell you, hey, I got to go back in and I got to make these curves go higher for this event that I'm running. Okay. Does that help?
Thanks. Yes.
Okay. Okay, then the last step actually was to, whoops, I should have kept that open, was to go to the options menu and edit the internal bridge cross sections, and we had to put in Manning's N values. I didn't change the main channel bank stations because this is just the bridge opening, so those are fine. Okay. And then we can look at the cross section. So here's the upstream internal. Okay. Here's the inside, upstream, inside, downstream. This is the center line. Now, what I like to do, look at the center line is like, okay, well, what is called center line weir? Well, that's what it's going to use for the weir profile for the bridge, because that's what you entered for your station elevation data. Okay. And this is the low chord of the lid, that it's going to use. And then this is the ground portion it's going to use. So if this is different than the train's going to be overrided for those faces. And it's going to use this ground. It's going to override the train on the centerline faces. So that brings up an important point. You can actually go in and go to options, and you can edit these internal cross sections. Okay, like these two, the upstream, inside, downstream. You can put a scour hole in there or whatever you want. And if you did that, then it will actually change this centerline cross section. And when it goes to run, it will change the elevations of the faces along those center lines to reflect that scour hole for the computations of the bridge curves, at least. Now, it's not going to change the terrain model in RAS Mapper, but for the computations of the bridge curves, it would do that. Then you were to save that, create a plan, run it, and then look at output. And then answer some questions. So if we go to RAS Mapper, before we go to the questions, here we have our bridge, and we have our no bridge plan and our bridge plan, and we can turn both of those on. And one common question that I was getting was, how do I see like output for both of them at the same time? So you always got to remember, turn on what you want turned on, but then click the results layer. And then when you animate, you're actually seeing the results for both of them. Now they're right on top of each other, but the other thing I can do is I can draw a profile line. And I had a centerline profile line in there for you already. And I can either right click on it over here and say profile plot, and then water surface, since I have that turned on. And I'm going to make that a little smaller, and I'm going to put it over here. And then I'm going to go ahead and animate this thing. And we can see the result of the water surface happening. Now, since I didn't have it maximized to begin with, I might want to stop, and then I can click on this and zoom out. Okay, so it's getting out of the plot, but I can readjust this plot without closing it and opening it. So there I can see the with bridge and without bridge. Now, I can also just stop this and say max. And then I can come over to this plot, and I can zoom in so I can see it closer, okay, right around the bridge. And then I can go back and look at that. Okay, looks like I have, I'm going to turn that off for a second. I had horizontal plotting on, not sloping, so that's why the plot looked funky. So if I ask for that again, now that I have the sloping water surface turned on, it's going to be a smoother plot. And when I zoom in, it's going to look nicer. All right, so let's get to the questions. So let's go down to where the questions start. So the first question is, how do the results for the with and without bridge compare? What is the water surface difference between the two plans at the upstream of the bridge? And so I just basically did that very thing where I went in to this plot and I zoomed in close enough and I looked at these two water surfaces, okay? And if I want to zoom in even closer, and so I can see that this point is 567.55, and I can come up here and I can see it's 567.78. And that's basically what I did. And what I came up with is there was about a half a foot rise, additional rise due to the bridge. And so thinking about that, it makes sense, because if we go back to this for a second, even without this bridge, these road embankments are causing a huge contraction, right? And so the road embankments themselves are going to cause water to back up, even if there wasn't a bridge deck here. Now, these road embankments wouldn't be there if this wasn't this bridge, but the fact that is in the train, and so your no bridge run has the road embankments in it, which are already causing a rise. So if we were actually doing a design we wouldn't have these road embankments, right? And that wouldn't be in the terrain. And we would have seen a much larger difference into the without and with bridge kind of water surfaces. There would have been maybe a couple of feet difference because the water surface would have no rise at all for the no bridge. But that's already in the terrain, so that was kind of in there artificially already. So that rise, most of the rise is due to the embankment itself, not so much the bridge deck and piers. It's the blocking off of the floodplain due to these road embankments. Okay, the second question was, what's the maximum difference between the water surface from the headwater side upstream of the bridge to the tailwater side downstream of the bridge? How did you find this answer? Well, there's several ways you could have done this. And so let's talk about a few. The first is you could have said, okay, let's just look at water surfaces. And I've got both water surfaces turned on. And one thing I could have done is I could have said layer values, and I can click on this water surface and I can say add, and then I can click on this water surface and I say add. And now by doing that, when I move the mouse around, I get both water surfaces from the two plans, but I only want the one plan, just the width bridge. And so here I can see I've got like 567.47. Here I got 566.8. But am I necessarily at the maximum difference? I would have to go through a lot of different time steps to know that. The other thing is if I hit maximum, does it necessarily mean that the maximum headwater occurred at the exact same time as the maximum tailwater? Well, no, it doesn't. So to me, another way to do this is to use the hydrograph plotter. So back on the main RAS, there's the hydrograph plotter, and I can bring it up, and I can select the type as the SA2D connection, which it did, and then there's only one, so there it is. And now I can see over time the headwater and tailwater, and I can kind of move around till I see the maximum. Okay, and it's over a foot, and so that's kind of what I did is I found the maximum difference from the hydrograph plotter. Okay. And I did that, and it came up with basically about 1.1 feet on January 2nd at about 312. So that's how I got the maximum difference. And then, does the bridge go into pressure flow? Well, unfortunately, right now in RAS Mapper, we don't have an option to plot the bridge deck when we plot that profile. So when we plot those profile lines, you don't get to see the bridge deck right here. Now, that's going to get added at some point in the future, but just this is a completely new capability, so there's not necessarily all the output we want. So in order to determine that, I had to go back to the input and say, well, what is the low chord of this bridge? Well, over here, I can click on it, and it's 566.85, but up here it's a little bit higher. It's 567.68. So how high did the water surface go, though? Well, if I come back here, I can get a time series for these cells of water surface, and it went up to 568. So it was well above at that cell right upstream, the low chord of the bridge deck. So the answer is yes, it did go into pressure flow. Okay, but did it overtop the bridge deck? Well, the top of the bridge deck was way up at 570 at the left and 571.6 on the right. So actually it did not overtop the bridge deck itself. It went into pressure flow, but it didn't overtop the bridge deck. Okay. And so that's how I came up with that. And then the last question was, is the left roadway approach, well, so the next question is the left roadway approach bridge deck or right roadway approach overtopped? and the bridge deck wasn't. So what about the roadway approaches? Well, we can see that in RAS Mapper. And what I like to do is for that is I like to turn on velocity. And then I like to turn on the velocity tracers. Now, let me turn off water surface. Okay. So here at this point in time, you can obviously tell this is not being overtopped, right? Because the velocity is all going this way. But as I increase this thing and turn on the tracers again, now there is some overtopping. Let's see what's happening here. Remember, these faces right here, this face is wet, right? On the upstream side. So that means water is higher than the face because the face is wet and it's dumping water into the downstream cell. Now it's not going to show water trickling down the downstream side of the embankment because the water goes from this cell right into that cell and it goes to the lowest point in the cell, and there's only one elevation per cell. But the upstream cells are higher than the face, so there is water going over. So that's why now we're seeing the velocity tracers are showing some velocity this way in addition to velocity contracting through the opening. If I zoom back out, that did not happen on the right-hand side. So what do you think about the accuracy of my model, though, to predict this? Any comments on that? Do you think I'm accurately predicting this overflow?
You need to add break lengths.
Well, I did actually add a break line and lined up these cells on what I thought was the best I could with the high ground. But the cells and the faces are based on the terrain right there. What do you think about the accuracy of this terrain in this area?
It looks like it's got some bogus triangles if you zoom into it.
Right. So one thing I like to do is I like to go to the terrain and go to image display properties, and I like to turn on the contours and then zoom in. Maybe I'll back off a little bit on some of the, well, that's not bad. So do you think that looks like a nice roadway, those contours? No.
No.
So this terrain is just not that accurate at picking up the top of the road. And because the terrain is not accurate picking up the top of the road, my faces are not accurate, even if I use a brake line, because they're just picking up the terrain. So let's turn off that contours. So how could I improve this model to more accurately represent this overflow? There's two options that you could do. Anybody?
Terrain modification.
I could use a terrain modification. So there's actually three options. So I could put in a terrain modification here and more accurately represent these roadway approaches. Yes, absolutely. That's one. What's another thing I could do?
Put it in a 2D structure.
Expand the bridge.
Those were the other two answers I was looking for simultaneously, but they were both right answers. Great job to the two people who said that. So one person said, I could put in another SA2D structure here and another one over here and override the terrain with station elevation data. And that's a great option. Okay. Or I could take this bridge and I could have extended the bridge all the way over here and also extend the bridge all the way over here. Now, I actually like the option where I create a separate 2D structure for this and a separate one for that. The reason is, let's say, what if I wanted to evaluate this road embankment breaching? The bridge capability in RAS doesn't have a breach option, but the normal SA2D structure where you're just using an overflow weir, you can actually put in a breach. So if I model the leftover bank as its own SA2D structure that's not a bridge, just a weir overflow, and this one is a weir overflow, then I retain the option of not only changing the station elevation data, but I can also put in a breach. And I kind of like that option, which is why on purpose I did this workshop with just the bridge opening for the bridge, so we could talk about that other approach. So there's three options. I could use the terrain modification tools. I could extend the bridge and override the terrain with the bridge station elevation data, or I could do separate structures, one for the leftover bank, one for the bridge, and one for the right over bank approaches. And then if I wanted to do breaching, I could do that with those structures. All right, so that's the workshop. Any other questions?
Hi, Gary. I have a quick question. You just discussed the multiple different options. What do you find yourself using the most often?
So most often, I just use the bridge for the opening, like this, because I want the 2D equations to be used for everything else. So if I have good terrain data, then I just make a mesh that lines up on top of it. If I don't have good terrain data, I would use the terrain modification tools to make a nice terrain. But I just use the bridge as the opening because in this, if I use the mesh to model this part, I can just use normal 2D equations for the overflow. Or if I still want to use a weir, like maybe this drop of water is too steep, and solving the 2D equations through a waterfall is not good. It's not going to calculate real accurate. But if I make this a separate structure, then I can use a weir equation and put its own weir coefficient for the flow going over. So I like the option of handling the overflows separately from the bridge curves because I have more flexibility. I can model it as weir flow, I can model it as 2D flow, I can do breaching, all of those things. Now, there's nothing wrong with making this whole thing one bridge, though. There's nothing wrong with that approach. Okay, but all the losses for everything are going to be wrapped up in those curves then, is the difference. Okay, any other questions?
Gary, was there a way to look at the water surface elevation profiles with the bridge? Did I miss that? Or
the answer was right now in RAS Mapper, it does not have the option when we look at the profile to plot the bridge deck. That's something we got to work on adding for. Right now, you can't get any structure inside a RAS Mapper on top of these profiles, whether it's a bridge or a dam or whatever. You can only get the terrain and the water surfaces. Yeah, so the answer is no right now.
okay.